Hello again. Welcome back. Hope everybody enjoyed their break time. Today, another short one. We're going to talk about Pareto distributions, sometimes called Pareto distributions. Pareto is an Italian name, so it'd probably be something like Pareto. Just my fake Italian accent there, if you want to pronounce it correctly. You hear a lot of people pronounce it kind of like burrito, though, because it has the rolling R, so like burrito with a P. Burrito, burrito. That's the joke in the little description blurb for this one. But Pareto distributions, I'm going to call them Pareto. Pareto distributions govern a lot of what we do in the world, and unfortunately you don't tend to learn about them too much. You tend to learn more about normal distributions, bell curves, things like that. Not a lot of things out there that follow normal distributions. There are a lot of things out there that follow Pareto distributions. Not to say that nothing follows a normal distribution, but most things in the world are Pareto distributed. Okay, and there's lots of math and fun stuff behind Pareto distributions. I'm not going to get into any of that. We're just going to talk about, in general, where you see Pareto distributions in computer science, how you should be applying Pareto concepts to the work that you're doing right now. Because this is your first major CS project, you haven't learned a lot of the difficult Pareto lessons yet, and some people don't learn those Pareto lessons their whole career. They go on thinking everything's going to be normally distributed every time, and they're surprised every time. It's especially a property of management. So the sooner you learn what's Pareto distributed, the better it's going to be for you. Let's check it out. So what is a Pareto distribution? It's known by many names. Some people call it the 80-20 rule, the 90-10 rule, tons of other names. Basically, a small percent of X is responsible for most of the output. We'll look at a couple examples next. Let's look at what that curve is shaped like. So it doesn't have to be big on the left like this. It can be big on the right instead. But you're talking about a function where most of the goodies are going to be biased towards one side, unlike a normal distribution where most of the goods, most of the productivity or whatever it is that you're measuring is biased towards the center, or it's normally distributed throughout, or a more even distribution where the whole area under the curve is distributed throughout the whole function. Something that's Pareto distributed, either most of it is at the low end or the high end of the curve. So this could be on the left, this could be on the right. Sometimes Pareto distributions are positive things, sometimes they're negative things. I'm going to try to focus mostly on positive things here, but I bet you can think of quite a few things that are negatively Pareto distributed. So let's just get right into it. Let's look at some things that are Pareto distributed in the real world. So let's look at a simple one, human population. 90% of people live on less than 10% of the Earth's landmass. They live in cities. So 90% of people live in tiny, very concentrated areas on Earth's landmass. You can also say that 100% on people live on 10% of the planets in the solar system. Look at that, another Pareto distribution. And a lot of people would suggest that life lives on a very small percentage of planets. We haven't discovered how many yet, but we're pretty sure that life doesn't exist that frequently. So it's probable that most of life exists on a very small percentage of planets. Going further galactic, 90% of stars are within a certain size category. 10% of stars are the giant stars that make up most of the mass of stars. 99% of the endless void of space is empty. 1% of space makes up most of the matter. That's super Pareto distributed, right? So there are all kinds of Pareto distributions. And then going even further on that, 99% of that space is empty. Only 1% of space is full of galaxies and things containing even more stuff. The areas between galaxies is vast and completely empty. So tons of natural things follow Pareto distributions. How you use your time. You'll probably find that 90% of your day is occupied by less than 10% of your tasks. Sleeping and working are big chunks of that. And then if you break those down, 90% of the time you spend, for example, playing games is probably populated by 10% of the games you own or less, right? So check out your Steam library playtime. Look at the games you've played the most. You've probably played 10% of your library for 90% of the time. And then in that sub-game, you've probably played whatever mode or whatever kind of thing it is 90% of that time, right? So if there's like a competitive or an uncompetitive, you've probably played competitive 90% of the time or more, right? So you have Pareto distributions all the way down and things like how you use your time. Wealth is a prickly one that people don't like to discuss, but wealth is Pareto distributed in almost every society around the world and throughout almost all of history. A small percentage of people control the majority of the wealth, 10, 90, whatever. And this actually goes repeatedly. So 20% of people control 80% of the wealth globally. You could say that the United States, for example, which makes up a very small percentage of the global population, controls a very large portion of the wealth. So you could say that North America controls a very large portion. Then you have a very small percentage of United States people, so Americans, controlling 80% of that wealth. And then if you break up those guys, 20% of those guys control 80% of that wealth, and you can pretty much go all the way up with this until you get to a very small population of people. It also works for income. It works for, because wealth is proportional to all kinds of other stuff like food and houses and cars. You can do it with all of those different things too. You can do it with property ownership. You can do it with all kinds of human possessions and things like that. You can look at it in terms of injuries or risks. 20% of hazards lead to 80% of the injuries. 20% of risks lead to 80% of the damage. You look at it in legal exposure and things like that. 20% of the potential risks you have lead to 80% of your damages. 10, 90, 20%. These are all rough, but these things are all Pareto distributed. A very small proportion of them lead to a very large proportion of the outcomes. And this is much more common than your normal distribution, your bell curve, where everything is at least distributed along normally. There's no big bulges at the tails. Most things are tail distributed. Not to say that nothing's normally distributed. Many things are normally distributed too, but much more is distributed on the heads and the tails than is normally distributed. So in computer science, how is this relevant to you? So the biggest point that I want to make, right, is that 90% of your time gets spent on 10% of the code. All right, that means that now, since you're, well over 10% done with class, I think we're, let's say, 3 out of 16, so we're something like 15, almost 20% done with class. You should be done, because it's going to take 90% of your time to fix the last 10%. You should be 90% done, which I'm partly kidding, but I'm partly serious too. The quicker you get to almost done, the faster you're going to realize how much there is at that almost done phase. Right? So you might be thinking, well, this is going to be a steady journey, and by the time we get to almost done, there'll be just a little bit more to do. But it's not going to be like that. It's going to be like by the time you get to almost done, you'll realize you've barely started. The old joke in computer science, you'll hear this one a lot. The first 90% of a project takes 90% of the time, and then the other 10% of the project takes the other 90% of the time. Not quite a Pareto distribution. This is implying that it's even. It's usually worse than that. The first 90% of the project takes 10% of the time. So the sooner you get to functional, mostly working 90% of the way there, the sooner you're going to run into the real barriers that are going to be the real time consumers. The problems you guys face now, I'm sure they're big and serious, and I'm sure they're complicated, but I guarantee you that the complexity spiral will only grow more and more vast as you get further along. So the faster you can get to the real complexity, the better. The faster you can power through this, the better. So iterate quickly, get your prototypes out fast, get your early working versions out fast so that you'll figure out what the true problems are. It's going to be pretty much impossible for you to figure those out until you get to them, right? So try to get to those problems as soon as you can. Talk about some other elements where it plays in CS. 10% of the developers do 90% of the work. That's a common adage that people make. 10% of developers do 90% of the work, and 10% of developers get 90% of the pay, which is not always the same people. Sometimes the people who do the work are not the people who get the bulk of the pay. You also have the negative version of that. 10% of developers make 90% of the bugs, and then 10% of developers fix 90% of the bugs. So are you a Pareto 10% distributed developer, or are you somewhere else? This is why the computer science hiring process has become so pathological, because every company is looking for that 10% dev. And people call them the 10% dev, or people call them the 10x dev or the 100x dev is a common expression as well. People are looking for that person that provides the output of 10 people. And they don't usually want to pay the pay of 10 people, but everybody's seeking that mythical person. That's why you see this insanely pathological hiring process in computer science where you have to do these ridiculous tests and all this other stuff. All right, and then in terms of your focus, right? So 10% of your bugs that you have are going to make up 90% of your problems. So you got to knock out the bugs that make the most problems. 10% of your code takes up 90% of your memory, 90% of your performance. So you want to be optimizing once you figure out what that 10% is. Don't optimize prematurely, because the code that you're optimizing might not be the one that takes up 90% of the time. Optimize once you've realized it. Most programs spend 90% of their time executing just 10% of your code. So make sure that 10% is the good stuff, right? But you won't know what that 10% is until later. So, not to be too gloom and doom, but give you a little bit of a sense of urgency. Try to get to the big problems fast. Try to fix only the bugs that make up the majority of your problem, and focus on the 10% Pareto stuff, and try to become a 10x dev yourself as well. Any questions, any comments before we sign off and get to work? All right, guys, enjoy. I will see you in your meeting soon, and see you next week.